The objective of this lesson is to solve a task involving comparing fractions, recognizing equivalent fractions, and adding and subtracting fractions. This is a task-based lesson with 4 problems. We will explore one problem and solve it different ways. Students are encouraged to solve the problems in a way they see most fitting. Zola and Kai are traveling with their families across the United States. Both families drove from San Francisco, California to San Antonio, Texas, a total of 1,733 miles. They traveled different fractions of the distance each day. What fraction of the distance did each family have to travel on day 5 to arrive in San Antonio? Let's first solve using a number line model. Draw 2 number lines to represent the distances each family traveled. Label the number lines from 0 to 1. 0 represents their starting point of San Francisco, and 1 represents their ending point of San Antonio. Let's record the miles each family traveled. Zola's family traveled in increments of twelfths. Divide the first number line into twelfths. Day 1, they traveled 2/12 of the distance. Start at 0 and go over to the 2/12 mark. Day 2, they traveled 3 more twelfths of the distance. Start at the 2/12 and go out 3 more twelfths to the 5/12 mark. Day 3, they traveled another 1/12. On day 4, they traveled 1/12 more of the distance. Now let's mark the distances traveled each day for Kai's family. Kai's family traveled in increments of 8ths. Divide the second number line into 8ths. On day 1, they traveled 2/8 of the distance. Start at 0 and go out to the 2/8 mark. Day 2, they traveled 1/8 of the distance. Start at 2/8 and go out 1 more 8th mark to the 3/8 mark. Day 3, they traveled 1/8 more, so go out 1/8 more to land at 4/8 of the distance. Day 4 traveled 2/8 more. Start at 4/8 and go 2 more 8ths to land on 6/8. The question asks how much more of the distance do they have left to go on day 5 to reach San Antonio? Looking at the number lines, the distance left to go can also be thought of as how much more is needed to get to 1. Zola's family has traveled a total of 7/12 of the distance. There are 5 more sections or 5 more twelfths to get to 1 whole. Record 5/12 for day 5 in the table. Kai's family has traveled a total of 6/8 of the distance. There are 2 more sections or 2/8 more left to get to 1 whole. Record 2/8 for day 5 on the table. Now let's solve the same problem numerically. In order to calculate how much more each family needs to travel to reach their destination, we must first determine how far they have already gone. This can be done by getting a total amount of the distance they have traveled. Zola's family has traveled 2/12 plus 3/12 plus 1/12 plus 1/12 for a total of 7/12 of the distance. Kai's family has traveled 2/8 plus 1/8 plus 1/8 plus 2/8 for a total of 6/8 of the distance. To find out the distance left to travel, take 1 whole minus the amount they have already traveled. In Zola's case, this would be 1 whole minus 7/12 equals the distance for day 5. 1 whole can also be thought of in terms of twelfths as 12/12. So the equation now reads 12/12 minus 7/12 equals 5/12 left to travel on day 5. For Kai's family, the equation would be 1 whole minus 6/8 equals the distance for day 5. 1 whole can also be thought of in terms of 8ths as 8/8. The equation now reads 8/8 minus 6/8 equals 2/8 left to travel on day 5. Let's answer another question using the table. After which day's travel had the 2 families covered the same fraction of the total distance to San Antonio? Let's use the number line to answer this question. Day 1 is clear that Kai's family traveled further. Day 2, it is clear that Zola's family traveled slightly more than Kai's family. Day 3, however, they match up. This is because Zola's family traveled 6/12 of the distance by day 3, and Kai's family traveled 4/8 of the distance. 6/12 is also equivalent to 1/2, and 4/8 is also equivalent to 1/2. Therefore, 6/12 is equivalent to 4/8. The objective for this lesson was to solve a task involving comparing fractions, recognizing equivalent fractions, and adding and subtracting fractions. We met this objective by solving a real-world problem in which distances traveled for two families were recorded using fractions. We added and subtracted fractions in order to discover the distance left to travel to reach their destination. We related fractions with unlike denominators to the benchmark fraction of 1/2 in order to compare.